The carbon wheel market is a competitive one, and today we're going to be discussing a new brand that is bringing an interesting option for consideration. While forge+Bond may be a new name, if you're a carbon wheel fan, you've likely already heard of their manufacturing name, CSS Composites. Forge+Bond recently invited us up to Bellingham to discuss their FUSIONFIBER manufacturing process and what sets them apart from the competition. Today, we're going to meet with the head engineer and head of marketing for CSS Composites' new in-house brand, Forge+Bond.
I'm the chief engineer at Forge+Bond and also a mad scientist.
So that's self-proclaimed.
Yeah.
Cool. Yeah. I am the marketing director at Forge+Bond.
The short version is I'm not a bike industry person, other than this is my only job in the bike industry. I did just about a decade in NASCAR. There's composites there. I developed and ran a composite shop at the first team we were at. Got my hands in there, all thermoset based stuff, and then through working in that industry, surprisingly, there's a lot of bike people. Started meeting a lot of bike people, and when I left the industry, stars aligned, and I ended up kind of right at the beginning of where CSS Composites and Forge+Bond started.
My background, I've been in the outdoor industry for, it's basically the only industry I've been in.
On the technical side, the engineering side, it started as a science project between myself and Joe Wheadon, one of our founders, trying to find some alternative materials to find different ways to make things. Joe being heavily in the bike industry, and myself being really into it, we went down the path of developing a bike wheel, and that was with CSS Composites. Back in 2018 is where we started. 2019 it really took off. We worked with a few partners there and really kind of learned and developed the recipe that we call FUSIONFIBER for this entire process. And in working with these partners, we kind of got to the point where we were ready to take it on and turn it into Forge+Bond and take it to the next level and really kind of start our own focused development R&D group. That's what Forge+Bond does, is we find the best way to use this material that we can and push that. The difference between thermoset and FUSIONFIBER, I mean, they're an entirely different class of material. The carbon is just about 60% of the volume is the same, but from that point on, it's entirely different, which requires the entire manufacturing process that we have and all the automations. You can't lay this stuff up in a mold by hand. It's physically impossible. You have to heat it up. You have to do our process of forging and bonding every step of the way to create it. The carbon that's in our product is the same carbon that you have in every other component out there. There's different brand stuff, but effectively the same. The matrix, the part that binds it all together, is a thermoplastic. That's the key difference. Everything you've used up to this point is almost certainly epoxy based to thermoset. Our process uses thermoplastic, and because of that, it's an entirely different way to design and think. The end product may look pretty similar as far as just visual attributes, but the kind of similarities stop there.
Feeling good. Definitely through the rougher stuff you notice on it. They got good I don't know, they got like a good feel like planted in the middle of the corner, and you can just like get in, get out, and then it's tracking better. I don't know, I feel like I can feel the difference today.
Being the material it is allows us to make it entirely in the US. It's highly automated. A lot of skilled trained operators running and programming equipment similar to more like CNC machines and robots to make this stuff than an army of people hand laying in the molds.
Every product that's out there that you basically see in the marketplace is a thermoset composite. That we are doing something uniquely different in all of carbon manufacturing, right?
Yeah.
So, our mix, our proprietary mix, and the way we set it up, and the manufacturing process of forging and bonding, so heat and pressure, gets us to an end result that gives us a super unique ride and a recyclable product, and it's also super clean. Like if you come into the facility, it's not like you're wearing respirators and there's epoxies everywhere and it smells and it's dirty. There's a reason why most carbon goods are not made in the States. Ours is made in central Utah, right here, and because it's clean. And the nice end result of that is that the product is not only great in performance, but you can feel good about purchasing it, riding it, and it's recyclable, and all the elements that go into that process is also as sustainable as it possibly can be. And the product, the waste, we actually waste nothing. It turns itself into other products, waste nothing, and it's everything that inspires how we go about it. It inspires our production, it inspires how we ride, it inspires how we attack or want to encourage others to go about their way of living. Like truly, don't waste the moment, don't waste life, don't waste the planet, don't waste the materials that we have in front of us. Let's use it. And it can inspire creativity as well, which you'll see in our assets. Like we can take what's considered junk, just like honestly the trimmings or whatever from our product.
That's a great point.
Yeah, I mean you can see like we make tire leathers. Now that's the easiest example to put. Whatever's left over from us making a wheel, you get a set of tire levers out of it, and that category of recycled goods from us will continue to grow, and it's a major focus for us. Yeah, I mean, there's also just the logistical element of it too, that makes it a cleaner process and a more responsible process. We're not shipping things from Asia to the U.S. or vice, around the world to create, a wheel, which is a rather simple product, right? Like we shouldn't have to circumference the globe to make a simple circle. Forge+Bond is, the name came about from the process.
The manufacturing process as a whole, it's quite a bit different than how a thermoset's done. But essentially, we start with a raw material like you would with anything else. Instead of being a big 5-foot wide roll of pretty preg composite that's all sticky and has to stay in a freezer, ours can just live on a shelf forever. You can pull it off. It's got no shelf life. It doesn't require any refrigeration, but it comes in a tape roll. So that goes on to it's a robot. It's an piece of automation where my group and the engineering group, we come up with a laminate and we program the laminate into this machine. And then where the big difference is from what you have to do on a thermoset is everything I have to make has to start out flat, and then I have to take that and I have to turn it into shapes, and I have to turn those shapes into other parts. It's kind of like Legos. It's almost like trying to come up with 3D puzzle to go together, that you can finally stick all these parts together into a final tool, then create the rim shape. So that's where the real magic is, and there's multiple processes along the way, but it's all automated. It's a super clean facility. It's heat and pressure when you do it every step of the way. This is another form of heat and pressure with the thermoplastic. You just keep doing it and doing it, and then because you can just keep heating and remolding it, it allows it to be recyclable, and it's a great feature. It can truly take the in-use product we get back, and we, on our warranty process, we take everything back. We want it back. It's valuable to us. It's not that we want to just say we're recycling it, so give it back. It's truly like, if we don't get that back, then I have to buy virgin material at X dollars a pound to make those other products we want to with our sister business. So it comes back to us, and the recycling process is pretty straightforward. You chop it up, and then you can then take that and you can make it's called an engineering grade thermoplastic, and you can mold it into about anything you can injection mold. You can pretty much make out of this. And we're still discovering different ways to work with it.
Well, that wraps up a few days in Bellingham riding with the Forge+Bond crew. I hope this video has helped shed some light on CSS Composites and Forge+Bond in specific, and how their manufacturing process is different than what you see on the market today with your typical carbon wheels. It results in a totally different end product that has a much different feel out on the trail. They're able to the wheels are able to have some compliance, but yet still be stiff when you need them to be in corners and G-outs and things like that. My initial thoughts are very positive, but I'm looking forward to getting out on some more rides and putting them through their paces over the next couple months. We'll come back with a long-term review for you guys, and thanks for watching. We'll see you out on the trails.